You've probably heard a ton about these generalist AIs, the ones that can do a little bit of everything. But what's really cooking now is something else entirely: AI specialists. These are models trained from the ground up for really specific, really high-stakes careers. And today, we're going to look at how they're landing the job.
I mean, can it really do the job? Not just spit back facts it found online, but actually understand super complex regulations, reason through tricky scenarios, and give advice you can count on. It's a massive question.
And what about a financial analyst? The kind of person who lives and breathes dense financial reports and has to perform incredibly complex calculations where there's just no room for error. Can a small, lean AI really go toe-to-toe with the giant all-purpose models?
Well, to figure this all out, researchers are basically sending these AIs to school. They're creating custom courses, specialized textbooks, and even final exams. So let's crack open their report cards and see how they did.
All right, so first up, we have a case from Amazon Science. Their mission? To train a hyper-specialized financial whiz kid. But here's the twist. They wanted to prove that a smaller, way more efficient model could be trained to actually outperform the industry giants.
So the challenge they set for themselves was, frankly, a little nuts. Could a pretty tiny 4 billion parameter model take on these behemoths that are many, many times its size and win? It's kind of like asking a go-kart to outrace a Formula One car.
Okay, so here's how they did it. And it's basically a two-step process. First, over on the left, you see dataset preparation. This is where they create custom textbooks for the AI. They generate thousands of financial problems and package them into a special format the AI can actually learn from. Then, on the right, you have post-training. This is where the AI hits the books. They take a general model and put it through these very focused lessons using those custom textbooks.
And these lessons for the AI came in two main flavors. The first one is SFT, or supervised fine-tuning. Think of this like giving the AI the answer key and having it practice over and over again until it just knows the right answers. The second one is DPO, direct preference optimization. Now this is a bit more sophisticated. This is like showing the AI two different answers, a really good one and a kind of meh one, and teaching it how to tell the difference and always choose the better one.
So, did it work? Oh yeah, it worked. The results here are pretty staggering. Look at this. Their little 4 billion parameter model, our go-kart, scored an incredible 78.64% accuracy. That's better than models that are 7 billion or even more than 30 billion parameters large. It just goes to show a highly specialized education can absolutely beat raw power.
Okay, so we've seen a financial genius. Now let's switch gears and put an AI through law school. This time, we're looking at research from Stanford Law School. And they took on a slightly different challenge. It wasn't just about training the AI. It was about creating a bulletproof test to see if it genuinely understood the law.
And this gets to the heart of the matter, right? An AI can basically memorize the entire internet. So how can you be sure it's actually reasoning through a problem and not just, regurgitating something it's already seen? How do you prevent it from cheating? Their solution was kind of genius. They built what they call a synthetic data set. You can think of it as a custom-made bar exam with thousands of totally new, randomly generated tax law problems. The key thing is, these questions had never existed on the internet before. This guaranteed the AI was being tested purely on its ability to reason, not to remember. And when they ran the tests, something really interesting popped out. Look at this chart. As the models got more advanced, moving from left to right, from older ones like DaVinci all the way up to that red bar for GPT-4, their accuracy just skyrockets. Researchers have a cool name for this: emergent ability. It's not just a gradual improvement, it's like the skill for legal reasoning suddenly switches on and gets way, way sharper with each new generation. Okay, so now they have their star student, GPT-4. The next question was, what happens if you give it a little help? Think of these as different kinds of cheat sheets. One was like an open book exam, where they gave the AI the exact legal text it needed to solve the problem. Another was more like showing it a worked example to give it a template for how to think through its answer.
And this is where things get wild. When they put it all together, the best model with the best study aids, the results just went through the roof. If you look at the graph on the left, you can see the accuracy climbing from a pretty dismal 30% all the way up to over 90% on some of these tests. It just shows the incredible power you unlock when you combine a really smart model with the perfect study materials.
So let's step back for a second. We've got a finance model and a law model. Two totally different fields, right?
But it turns out they both point to the same playbook for creating these super skilled, specialized AIs.
And here it is, the secret sauce, in 4 simple steps. Step 1. You create custom textbooks filled with high-quality, specialized data. Step 2. You run focused drills using fine-tuning techniques to teach it the right way to solve problems. Step 3. You give it open book access to the exact information it needs right when it needs it. And finally, Step 4. You literally teach it how to think by showing it step-by-step examples.
Okay, so this is the part where we all start wondering, right? If an AI can score over 90% on a specialized law exam, are the human experts, well, toast?
Well, before we get too carried away, the researchers themselves pumped the brakes a little. And this quote from their own paper really says it all. Even with all these tricks, their best model still isn't as good as a professional tax lawyer who, as they point out, is expected to get these questions right with near-perfect accuracy. So, bottom line, we are not there yet.
But, and this is the big but, think about that chart we saw, the one showing how quickly these models are improving. The real question isn't whether they're as good as a human expert today. The real question this research leaves us with is, for how long will that still be true?